Aloha, Richard Halverson here. This is ITS148. And in this video, I'm going to go over Lab 18.8, which is the natural merge sort. So let me share my screen. Okay, you recall the regular merge sort recursively divided the list in half until it got down to where the lists were only one element long, and a one element list is sorted. And then it merged sorted lists, it merged pairs of sorted lists together into larger sorted lists until there was just one large sorted list. A variant of the merge sort is called the natural merge sort. That's what we're going to do here. And instead, what it does is it looks for already sorted runs of elements and then merges those together. So, for example, let's say you have an unsorted list that looks like this, and this is an unsorted list, but it actually consists of 1, 2, 3, 4, 5 sorted lists, because the first 3 are sorted. Then we start over again. The next 2 are sorted. 70 is all by itself, and that's sorted. 23, 64, 74, and 81, that's a sorted list, and then 55 is also a sorted list. So this particular random list has got these sub lists that are sorted, and let's name them A, B, C, D, and E. And so the way natural merge sort works is it starts at index 0. It finds the first sorted list, which goes all the way up to the 96. And then it finds the second sorted list, which is only just 70. No. Let's start back here. Okay. It starts by sorting. The first sorted list is these 3, 17, 58, and 96, and the next sorted list is 24 and 88, and it merges those 2 lists together into what we call, which we're going to name F, because the next letter after E. And so this one, F, is 5 elements. It consists of the elements of A and B, but it's sorted. So the 17 is here, and then there's 24. So the 17, then 24, then 58, then 88, then 96, and that's how that got sorted there. Okay, and then it goes. Then it actually continues on, and it finds the next unsorted list is the 70, and the next unsorted list after that is this 23, 64, 74, and 81. And so that's 2 lists that are sorted, merges those 2 together, and we get 23, 64, 70, 74, and 81. That's these 5 here sorted. Okay, and then it starts again, and it finds one sorted list, which is 55. There's no second sorted list, so it resets, and it comes back to the beginning and starts again at the beginning, and it finds the first sorted list, which is F, and the next sorted list is G, which is this, all these 2 sorted lists, merges those together into this sorted list H, and then it looks for another sorted list E, and then that's the last one, so it starts back again, finds the first sorted list and it's H, and the next sorted list is E, merges those 2 together, and we end up with this final sorted list. Okay, so that's how the natural merge sort works. And in this video, we're gonna start by implementing. Okay, let's see what they give us. This is the code down here. It turns out, see, this is the. Let me refresh this thing, so it looks like here 18.8. So this is how it looks like when you get it, you're looking at main.py, and it turns out this program works where we have to add our code is not in main.py, but in natural merge sorter.py. go in here, and we have to add code to implement this get sorted run length and the code for this natural merge sort. Okay, so get sorted run length is the code that will determine, let's say we're at the beginning, you say start with 17, it will return 3. If you say start with index 0, 1, 2, 3, start with index 4, it will return 2. If you say start with index 0, 1, 2, 3, 4, 5, it'll return 1. If you say start with index 6 right here, it's going to return 4 because it's a string of 4 here. Okay, so that's what get run length. Get run length. We're gonna first we're gonna implement get run length, and so what it takes in as parameters is the integer list, and then the start index, and it's going to return the how long the list is, starting with the start index, how long the list, consecutive elements are making up a sorted list. And of course, a single element is a sorted list. So the smallest thing it's going to return is a 1, but the largest it's going to return would be the length of the list. All right, so so to write this code, we have some hints. Okay, what I'm going to do first is I'm just going to run this thing so we see what it looks like. Okay, it is put. It'll execute because it's got returns here. For this one, it's always going to return a length of 0. And for this one, this is in this method, we actually do the sort. We are passed into it as a parameter, the list that we're going to sort, passed to the unsorted list. And when it's done, it's this list that it passed in will be sorted. Okay, it's a list, so it's mutable, so we can pass it in as an argument to a method, and that method can mess with it. And when that method is all done, we can look and see the list, and it will be it may have changed. If the method changed the list, then we will see the changed list. Okay, so this is what we're going to do second. This is what we're going to do first. So the strategy here is we're gonna okay, so first I'm gonna run this and see what it looks like. Okay, I'm just gonna run it. Yeah, because the way this works is it has a bunch of test cases already. It's got a bunch of test cases set up already, so it's not going to be expecting any input. It uses this. This is how it runs the test cases and so on. We don't really need to worry about that. Let's just run this and see what happens. And we see this is the result of all the test cases. They all failed except for the first one. You see this. And so here we see that this is the list that it's going to test with. And it calls get sorted run length because it's we're asking it to return a length, and with start index 10. And what it says up here is we're supposed to implement get sorted run length inside here, and it takes as 2 parameters, an integer list and a start index, and the method returns the number of list elements sorted in ascending order, starting at the start index and ending either at the end of the sorted list or ending either at the end of the sorted run or at the end of the list, whichever comes first. And so this method is going to return an integer value, which is the length, how many of them there are, but it returns a 0 if the start index is out of bounds. So if the start index is like let's say it's got 10 elements, if the start index is 11, actually if it's 10, then that's past the end of the list. Then it would return 0. So anyway, so when we ran this thing, we tried with the start index of 10, which is past the end, and we expected a 0 because if it's past the index, it's going to return 0. And lo and behold, it did return a 0, so it passed that test. Well, that of course it passed the test because it's always going to return 0, as you notice. It's always going to return 0. But for these other tests, it failed the rest of them. So for this one, start index of 0, it expects a return value of 10 because this comes after the 23 comes after 15. 23 is see it, this list is in ascending order. It's actually a non from here to here to here. Oh yeah, okay, it is all the way up to the end. It's the return value should be 10 because that's how long the string is. That's how long it is. It's this list is sorted already, so this is the lowest and the highest, so it should be 10 and return 0, so it failed. For this one, if the start index is 3, 0, 1, 2, 3, if it's here, from here to here, is that sorted? It is all the way, so the string is 1, 2, 3, 4, 5, 6, 7. So it expects a 7, it gets a 0. To the next one, the start index is 0, and it expects a 3 because 1, 2, 3, and then it's over, so it expects a run of 3. It got back at 0, which is the wrong answer. This is the same data with the start index of 2, 0, 1, 2, and it should just return a 1 because this itself is sorted, but this is not. It's not sorted anymore. So it should expect a 1 back. It got a 0 because anyway. So that failed. So now you understand how this first thing is supposed to work. And the second one, where we actually call natural merge sort, this is the input, and it looks at the output, and we see that the output is not. The output should be sorted, and it's not. So that failed. Anyway, so let's enter in the code for get sorted run length. All right, I'm gonna put this over here, and I actually have another copy of the same. Another browser open with the same thing here because I want to look at these hints here. So it comes in with integer list and start index, and it returns the number of list items sorted starting with the index, ending either at the end. If it's return 0, okay, so let's take care of the 0 first. The 0 one first. I'm going to go if the start index is greater than or equal to the length of the integer list, if that's the case, then just return 0. Okay. In fact, I should just, well, okay. Otherwise, I need to, let's start with the length of 1. Length equals 1, because it's gonna, by default, always have 1. And by the way, I'm gonna end up returning the length. So I'm just gonna put return length right here because I'm gonna calculate the length. Here, right in here. And to calculate the length, I'm going to start a for loop, I think. Yeah, because I can exit exit directly out of a for loop. I guess I can use a for loop. For I'm going to start an index, just an index I in the range of the start index plus 1. From there all the way up to the top, which would be the length of the integer list. Okay, so this is the range. You know, this is this is the first one, and this is the last one plus 1. So it's not gonna so the range will be from start index plus 1 all the way up to the length of the integer list minus 1. Right. And so right now the length is equal to 1, and so I'm about to test the one following the start in. Okay, this is start index. That's the start, and now I is equal to start index plus 1. So I'm going to say is if integer of if start index plus 1 I, if the one the one just before start index plus 1, that has to be if it's greater than integer list of I. Okay, so I is the element at start index plus 1. And we want to compare I with the one before it. The one before it better be less than or equal to the one at I. The one just before I must be less than or equal to the one at I. If it's greater than the one at I, then we have a problem. Then we're done. We just return this because that's what it is. Okay, so we're going to say we're just going to return length. Otherwise, if we make it all the way to here, then that means that the previous one must be less than or equal to the I, which means the string continues. So I'm going to say length equals length plus 1. And this just keeps on going. This just keeps on going because, and it's going to come back around. It's going to be the next one. And each time, if it's ever the case that the one before it is greater than the one we're looking at, in other words, the one we're looking at is less than the one before it. If ever that's the case, then we're done. We're just going to return length. We're going to return the value, and we're done. Otherwise, we keep on going until we either exit this way, or we exit because we've reached the top of the list. If we've reached the top of the list, then we're here. Then this for loop is done, and we execute this line, and we end up returning the length. So you see, when this method starts, we're either going to exit, we're going to return this way, or we're going to return this way, or we could return inside this loop if as we're looking for the next element in our sorted list, in our ascending order list. It's actually non-decreasing order. It's not ascending because ascending implies that the next one is greater than the previous one, which is not the case here. But anyway, that's a detail. So anyway, I think we're done. I think that length is going to return the it's so this loop here is, we are, let's say it's this one here. It's going to start out, this is it, start index of 0, and so the for loop starts with start index of 1. It says, is this less than the one before it? No, it's not. So we keep on going. Is this less than? No. Is this one less than the one before it? No, it's not. It's greater. Is this one less than the one before it? No, it's greater. Is this one less than the one before it? No, it's greater. Is this one less than the one before it? No, it's greater. Is this one less than the one before it? It is less than the one before it. So then it returns. And at the moment it returns, length is equal to 5, and that's what the answer you want is. And it doesn't care what it doesn't care, once this where are we? Once this happens, it doesn't matter anything else in this method. It's all just abandoned. And we go back to we go back to where it was called. And by the way, where was it called? I think it's called down in merge. Let's see, can I run this? What? Yes, I should be able to run this because get sorted run length. Anyway, all right, I tell you what, I'm going to try to run this and see what happens. Run the program. Well, it ran at least. Let's see. Oh, look, a bunch of these passed. So I put in 10. Of course, that one passed. I put in 0 and look at return 10. It expected 10 and it got 10. I put in started index of 3. It expected 7 and it got 7. Okay, so it looks like my code worked all the way up to here. Obviously, because I didn't have that. I haven't done that part yet. And I guess I didn't go through tracing through how these test cases execute, but I think it's in this run length test case, which is down here. This is where the thing we just wrote is called get sorted run length. So this is where it's tested. Anyway, we don't have to look at that. What we have to do now is finish natural merge sorter. So we passed. So it looks like we've implemented step 1. Now we're going to have to implement step 2. A little bit harder. Okay, so implement step 2. Right here, natural merge sort. So I'm going to go down here because this is where I'm going to type in the code. My code is going to go right here. All right. So implement the natural merge sort method, and here it must do the start at index 0. Okay, we're writing main code here. So I'm going to say that I'm going to have I1 is going to be the index of the first run, and I2 is going to be the index of the second run. So first of all, let's say for this one, I1 is going to be there, and I2 is, and I want to find I2 right here. So I want, so So when I pass in, natural merge is going to call merge, and merge is going to, this is the set of numbers, this is the list. This is going to be the very beginning. This, like the first time, this is going to be 0 because the 17 here. 0. This is going to be 0, 1, 2, 3. This is going to be 3. No, I'm sorry, left last. This is going to be 2. 0, 1, 2. Left last, and this is going to be right last. And this, so this is going to be 0, 2, 3, 4. This one's going to be 4. The first time this is called, this is going to be 0, this is going to be 2, and this is going to be 4. The first time this is called. Before this is called, this will be called on I1, on the first one, to find the 3, and then the 3 is going to get added to I1. Yeah, the 3 is going to get 3 minus 1 gets added to I1. Anyway, from there we figure out where I2 starts, and then we get a length of I2, and then we figure out what these 3 parameters are, or these 3 arguments are, passed into merge, and we don't care about merge. We just care about this here. So I'm going to call I1 is going to be the index of the first list. Yeah, the first sorted run. So I1 is going to be equal to 0. It starts out at 0. Then now I need to figure out how long, what the run is. The answer is 3 for the first one, but I got to find that out by calling, and I'm going to call it run 1 length, I guess. I'll just is equal to I got to call this one here. Got to call that, and so I got to do self. Got to say get sorted run length, and it's the list, the integer list that comes in here. Integer list, that's the whole thing. Starting at I1. So this is gonna, first time this runs, it's gonna return a 3, because that's how long it is. 3. Okay. And so we're gonna start a while loop here, and what's gonna happen is okay, run 1 or I1 is always going to be the first one, and I2 will always be the second. And we're always going to start out with asking what the length of the first one is. If we ever test the first one and the length is the size of the list, then we know we're done. Okay, so that's how we know we're done. So that's going to be the terminating condition for this while loop. And this while loop is going to run until we're done. So I want to say while run 1 length is while it's less than the length of the integer list. It's equal to, if it's equal to the length of the integer list, then we're done. But while it's still less than the length of the integer list, we're going to start. We're going to figure out what I2 is, and then we're going to merge I1 and I2. So we know that. Okay, so now we're going to say now we have to figure out I2, and I2 is going to be, it's going to be I1 plus the run 1 length, right? Okay, so if I1 is 0 and the length is 3, then I2 is going to be 3. If I1 is 0 and the run length is 3, then I2 is going to be 3. 0, 1, 2, 3. It is. So I2 is 3. So this is 0. The run length is 3. 0 plus 3 is 3. So that's what length, that's where I2 starts. And now we need to figure out what the length of the run starting at I2 is. Okay, first we got to figure out if I2 equals the list's length, then the run starting at I1 goes up to includes the last item in the list. So that it's like we're down here, I guess. If I1 is this, I2 is this, and I2 is equal to the length of the integer list. No, it would not be equal. If I2 is equal to the length of the integer list, that means it's passed. Okay, so that means we've done something like this, where this is I1. Say this is I1, this is I2, those are merged into this, and then next I1 is 55, and then I2 is past 55. I2 is the length, I2 is, or I1 is 9, and I2 is going to be 9 plus 1 is 10. I2 is 10. I2 is greater than the length of the list. No, I2 is equal to the length of the list. Then that means that we have to restart. So I1 is here. I2 is beyond here. So we can't do I1 over here. We have to reset I1 back to the beginning again. So that's what we're going to do here. So we have to say if I2 is equal to, can be greater than or equal to, but probably equal to is fine. Equal to the length of the integer list. In other words, if I2 is past the end, then we got to start over. We have to reset everything back to the beginning. If I1 is here and I2 is off here, then we got to reset I1 back to here again. See up here, if we go I1 goes to I1, I2 starts here, I1 here starts here, I2 starts here, I1 starts here. You see, so that's what we're doing. We keep on going until in all these cases, let's see, I1 starts here, I2 starts here, I1 starts here, and I2 starts here. Okay, so that one would work. Here, I1 starts here, I2 starts here, I1 starts here, and then we'd have to reset it again. So that's what's going on. All right, so if I2 is passed, then we need to reset I1 back to 0 again. I1 equals 0. Okay. If it's not passed, then we can go ahead and try to figure out what the run length is of the second one. The second run's length. And that's going to be self get sorted run length of the integer list starting with I2. So give me the run, give me how long the sorted run is starting at index I2. So the first time around, it's going to be 2. It's going to return 2. This is going to be the I1. I1 is going to be started here. I1 is going to equal 0. The length is 3, 2, 3. I2 starts at index 3. The length is 2, 1, 2. Okay, so that's what that's going to be. And then so we have the so we have the length of the second one, and so that means that we have a left first, I'm just going to call it left. I guess I can call it left first is equal to the I1. Left last is equal to I1 plus, no, left last 0. It's going to be I1 plus run 1 length minus 1, because it's the index of the last one. It's not I1 plus run length is what I2 is. Last left is the last one of the first run, so it's the index of I2, which is that minus 1. In fact, I can actually go like this. I2 minus 1. That's what I'm doing. And then the right last is equal to I2. Well, it's equal to the last left plus. Well, we can do it this way. It's equal to I2 plus run 2 length minus 1. Okay, so it's actually the index of the last element, not the index of the one past the last element. So that's what right last is. This was left last. Okay, and so now when we have all those things, we can call merge. And so I do self merge of integer list, followed by left first, followed by left last, followed by right last. Okay. And so now they've been merged. So it's like now we're like right here. Okay, so we've just merged A and B, and now we want to make this one be I1, because we're going to continue. This is going to be the new I1, and this is going to be the new I2, and this is going to be the new right last. But anyway, so we want to identify this list and this list and merge C and D into what's G. So we need to so now the new I1 is going to be equal to whatever right last was plus 1, right? It's going to be the one after right last. And now we got to check where I1 is. If I1's off the end, then we know we got to do the reset thing. Okay, so if I1 is greater than or equal to, if it's past the length of the integer list, integer list. If it's past the end of the integer list, then we got to reset I1. I1 equals 0. Okay. So anyway, so we either have I1 is ready to go here, or we have I1 is was here. No, I1 is here. No, that would be here. I guess it's anyway, if I1 is past the integer list, just like this, we said I1 equals 0, just like we did up here. If I2 was past the integer list, we set I1 equals 0. And then we're back here and we're just gonna compute the run length again. Outside of this else case. equal with this else case. So we're back here. And we want to compute the run one. So I1 has been reset to 0. No, I1 has either been reset to 0 or I1 is like sitting here at 70. And we want to get we want to continue by getting the run one length. Which is going to be equal to self dot get sorted run length of the integer list starting at I1. So here we go in with I1 and the run length. Here we go in with I1, whatever it is, and its run length, whatever it is. This should be I1. And we come back around in a loop, and as long as the run length is less than the integer list, then we're fine. If it ever reaches the length of the integer list, then we know we're done. So I don't know. This looks this is done. This could be done. This could work. Let me just run this. Well, that looks pretty good. So I think I will leave this for you. I will leave this for you to submit, and you should get all the points. Hope this helps. Thanks for watching.